Hello, Tom here from Automotive Manufacturing Solutions. I'm joined here today with Georges Ayoub on a lab tour at the University of Michigan Dearborn campus. We've had a really good tour today, seeing some of the advanced manufacturing labs, seeing some of the student work as well. A lot of interesting stuff going on. Just thinking about some of the stuff that we have seen today. What are the projects that you guys are working on? Just explaining a bit to our audience and some of the goals across the labs that we've seen.
Right. So we've been able to see 3 different labs today. A lab on batteries and development of batteries and understanding how those batteries are reacting to the use of consumers, mainly, for example, with the different charging conditions and how that will affect the capacity of the batteries. We went also to the driver simulator. That was fun. Everyone tried to drive this simulator. This simulator is a 6-axis simulator, and it allows to simulate any road conditions and driving conditions. And this is essential because we need to understand how people trust autonomous driving, for example, and the different driving scenarios, and we need to understand the habits of people in driving, because this is essential information, and this is again data collection to provide the designers, the engineers, with those information so they can make an informed decision when they design their vehicles. And the third lab we visited, which is a collection of 3 individual labs, but it's the same center on advanced manufacturing, where we worked on we work on building digital twins. So I've been talking with some of the attendees that we are living in a world that needs a lot of data. And we are living in a world, either we are in a data desert or a data accessibility, restricted accessibility area. And data desert means there is no data at all. And we are building platforms with sensors that capture all the aspects of the process itself. So we can collect data, and hopefully with time we can share them with the community, and that will help advancing the processes and the quality of the products that we are developing. And either or those data accessibility is limited because of all the walls we have and the boxes we have put it in, and here we'll have to go and unpack those boxes, and we have to apply all the different tools that now exist for mining those data. And this is what we can do here at the University of Michigan Dearborn.
You mentioned data, and it feels like everything today is kind of the heart of it has been data. You guys are collecting a lot of data. Is that the goal, to collect as much data as possible?
We are going toward digitization of the manufacturing processes, and data is the core of digitization. We have been collecting data in Industry 4.0, the era in which we are living now. We put sensors on almost everything, but we didn't know how to use the data. This data is lost on servers, is lost. Part of the data is reduced while it's transmitted to the server. So the data that exists is a raw mineral that needs to be processed. And I can give an example. You have iron ore, you make from it steel. So the same thing. The data that exists is a raw data that needs to be processed. And now a lot of effort are moving toward this direction. And since the data is the core of advanced manufacturing, because data is used to train any algorithm that will emulate the process. So this is essential, and this is the direction the field is moving in or towards.
And obviously that plays a big part in digital twins as well. So, what are your goals? What is the campus's goals with digital twins?
We are trying to be the leaders in developing digital twins and developing digital twins technologies. Well, probably we have to set the definition straight about digital twin. Often digital twin is used loosely and as a terminology, and we would refer, for example, to a CAD as a digital twin. digital twin is beyond CAD. It's beyond the digital model that we have on a computer. So that's why we have different levels of the digitization. We have the digital model, we have a digital shadow, and we have the digital twin. In digital twin, we have a physical model and a digital model with a seamless communication between the digital model and the physical model. And that's what we make a digital twin a digital twin. Means that we can intervene at any moment, and this intervention can be automated without human intervening. And the purpose is to make the manufacturing more efficient, reduce the cost, and mainly here in the U.S., become a hub for manufacturing. And often what would make the manufacturing difficult in the U.S. is the cost of labor. So the defects that the manufacturer will create. So now if we reduce the defects, so we will be creating what we call zero-defect manufacturing. And if we are able to reduce the intervention of human in the process, we will make very high efficient process at lower cost that can compete with manufacturing in other countries like China, for example.
Of course. And that is obviously something that we're going to be discussing quite a bit throughout the conference. Process improvement, quality. So, is the industry telling you that this is, what is the industry telling you? The campus here, the work that you're doing, are you going in the direction that the industry is telling you? Are you guys doing your own thing?
Right. So this is clearly there is an industry need in digitization, and this industry need in digitization is not only associated with the industry itself, but also there is a pressure, government pressure. So government. I mean, we know in the U.S. we have now taxes on every product that is produced abroad. If we want to reduce the cost of bringing products to the U.S., we need to bring back manufacturing. So if we want to bring manufacturing back to the U.S., we need to make the manufacturing processes in the U.S. More efficient and cost efficient, as well as efficient in production efficient. And the only way forward is through digitization. The industry understand that, we understand that, and we are trying to support each other in this process. So one of the projects we had was funded by Ford. It is on a stamping line. So we digitized a whole stamping line that is in production stamping line, and we are working on creating the digital twin. It's not an easy task, right? Because so many aspects for creating a digital twin. But this is based on industry demand. So clearly the industry is aware of the importance of digitization, and we are working in collaboration with industry to help achieve this objective.
Georges, thank you so much for today. But first of all, thank you, to the staff, students for having us. You'll be obviously joining us at the event, adding to the conversation.
Thank you for including us. And I think it was a very successful event, and university and industry needs to partner all the time. So we are serving industry. So
thank you.
Perfect.